first component is known as FC. Also, we can call it as frequency converter. Frequency converter will receive 400 volt, then we'll step up it to 440 volt to send to the transformer for step up purpose. Next component is single phase AC voltage test transformer. Test transformer which can be used for AC voltage generation and as high voltage supply for DC and impulse voltage configuration. This transformer can be set up to 100 kV. This component is measuring capacitor, which has the capacitance value of 100 picofarad. It can support up to 19.3 kV. This component is grounding switch. This switch is controlled remotely, and the purpose of this grounding switch is used to ground the high voltage construction kit. Next component is electrode. The purpose of electrode is to reduce the corona discharge on high voltage parts of the different configurations. Next component we have is connecting rod. Connecting rod acts as a conductive connection element and is made of aluminium. Next component is connecting cup and floor pedestal. These two components will act as a conductive connection element. The next component is called SEK-AC, a secondary unit for AC divider which incorporates the LV capacitor. It connected between the HF socket of measuring capacitor and the picoscope. The next picture is the inside of SEK-AC. Next component is called copper braided. It's used for grounding purpose or safety purpose.
When we press the emergency button, it will immediately de-energize and isolate the entire high voltage supply, preventing access to hazard and voltage until all interlock are reset and safe conditions are restored. This is isolated mechanism. It will measure our door fully closed before we start our lab. And the system will calibrate with the safety lamp or alarm, which is have a green light or red light, and it will tell us the area are safe before doing our lab. This lamp is connected with FC, which is lamp plus horn outlet. Supply will come from the control room and supply to FC, and the supply must 400 kV. There is 3-phase supply. There is 5 cable for supply, which is 3 live, black, brown and grey, 1 grounding and 1 neutral. After that, the voltage will through the black box, which is transformer in FC, and increase the voltage to 440 kV. The FC will supply other transformer that need 440 kV from this outlet.
So for the next step, let's begin with the wiring process from the frequency converter to the transformer. We are going to use the orange connector wire. Plug one end of the orange wire into the frequency converter. Then take the other end of the wire and plug into the transformer. Make sure to match the wire color correctly. Blue to red, black to black, and green yellow to the grounding, also known as earthing. For the primary winding, it is connected in series between terminal 2PX and 1PU.
First, put a grounding switch on floor pedestal, and then we use 100 picofarad measuring capacitor and install on a grounding switch and floor pedestal. Make sure stick of grounding switch not close with electrode. Install the electrode on measuring capacitor, and then put a connecting cap on electrode. To connect a transformer, install a connecting rod on connecting cap and connect with transformers.
So we proceed to grounding process. Prepare the copper braided and ensure the copper braided has a pre-drill hole for easy attachment. Unscrew the nut from the transformer grounding terminal and insert the hole and the copper braided into the terminal. Secure it properly and tighten the nut. Make another hole at the same copper braided for the next connection and unscrew the nut from the floor pedestal grounding point. Place the second hole of the copper braided into the pedestal terminal and screw it tightly. For the grounding CB impulse, unscrew the nut from the CB impulse bracket and attach another copper braided for the CB bracket for the pedestal ground. Use a jumper cable to ensure a firm connection between the CB bracket and the pedestal. So for the CB impulse connection, connect the male coaxial cable with capacitor. Locate the two port of the CB impulse unit. At the first port, insert the black connector. Connect a male connection cable to the black connector. Make sure a 100 picofarad capacitor is connected in series with the coaxial cable at this point. At the second port of the CB impulse, insert another black connector. Connect a T-junction fitting to this black connector. Connect one coaxial cable from the control room and another from the frequency control to the T-junction. The end of the FC coaxial cable will be connected to the channel 1 of the frequency controller. Last but not least, ground for the frequency controller. Connect a ground switch for the frequency controller unit and ensure this switch is properly grounded to protect the system.